welcome back to Cody Brainy. So, in our previous session, we talked about binary search tree, and in this section, we are actually going to discuss about how we can find the height of a binary search tree. So, if you recollect whatever we discussed so far, so binary search tree has a ground rule, right? So, when you try to insert a specific value at the node, then that value, if that value is less than the current node, less than the insertion node, then it will go to the left side. If it is higher than the current node, then it goes to right side. So that's the ground rule. And then we discussed about the level of a binary tree, level or depth of a binary tree. Level is actually related to the generation of nodes. And when it comes to height definition, height is something uh, which is the number of nodes uh, along the edges of a tree, starting from the start node to the leaf node. So it's a count of nodes along with the edges, starting from the root node, ending with the leaf node. So this algorithm, we are going to discuss about the algorithm to find out the height. So this algorithm actually find out the height of a binary tree. So the beauty of this algorithm is the recursion is at its very best. I really, amazed to see recursion in action to find the height of the tree. So the main advantage of recursion, what I observed is it can reduce considerable amount of lines of code. So let us create a binary tree now. Okay, so keep that rule in mind, the ground rule in mind. Higher value to the right, um, lower value or the less value to the left. Okay, so I'm going to create a tree with 5 4 8 2. So let us create 5. So that's a root node. Then I'm going to insert 4. 4 goes to left, 8 on the right, and 2 will be on the left side, right? So it will compare here. It is less than 5, then it goes here, then it is less than 4, so it should go to left side of the 4. So you see that. So this is our tree. Okay, now I'm going to find out the height of the binary search tree. So what I will do is, uh, first I need to go to the left, right, and then go to the right. We need to perform that operation till we reaches the end of the node. Okay, and then when it goes back, we need to count the nodes. Okay, the count the basically, yeah, the edges or the node. So the height of the binary tree here is 1 2, and the root node will contribute 1. So 1 2 and 3. So 3 is the height of this binary search tree. So in an algorithm, how we'll find out is, first we'll traverse to the left recursively. Okay, recursively traverse to the left, but we will also recursively traverse to the right. But that operation is second in the stack. So when we do recursively to the left, when we reaches this node, then we do recursively to the left and recursively to the right. So every node will do that. Every node will perform that operation, recursively to the left, recursively to the right, so that we can uh, traverse. We can make ensure that we visited all the nodes, and then while returning back, when the recursion returns back the uh, result of that function, right? Then it is going to return a counter 1, and it will add up. Then we always take the highest of the height. So assume I have assume let us remove 2. So that will be like, okay, I'm going to remove 2. Okay, I'm going to remove 2, and 2 is removed, right? So this is another example I'm telling, like to explain recursion, this is the best binary tree structure. So I am at the root node, then I am going to call height of 5. Then this is a recursion, right? It will first call height of 4 and then height of 8, because it will first call height of uh, left and height of right node. So it is going to call height of 4, okay, and then height of 8. Height of 8 will be in the queue. The first execution is height of 4. It returns 1. Okay, it returns 1. And height, then when it returns the result, height of 8 is in the queue. It will start executing. So height of 8 will return 1. So what it does is, then we can take the maximum of height of right and height of 8. Okay, sorry, height of height of left and height of right. The max of height of left and height of right in this case is 1, right? The max of 1 and 1 is 1. Then it should return 1, and we should consider the node height as well. So 1 plus 1, 2. 2 will be the height of this tree. So I hope you got the concept, right? So let us do the algorithm explanation in some more detail, so that we will exactly understand the concept, because this is very very important to understand the concept. This will help us to do upcoming complex data structure operations. Okay, so let us go back and see the algorithm. So you see, this is our data structure, right? 5 4 8 2. Now this is the algorithm. Don't think about I even if you see it's test.java, it's actually not a real Java program. This is kind of a pseudo code. Okay, I put it like this for explaining the algorithm. Okay, so this is the method height. Height is the method. It is accepting a node argument, and if you see, a recursion will be always having a termination node, right? A termination. For example, if it recursion means it will go through all the nodes. When it reaches the end, it will terminate, and then it transfer that control over to the next waiting function, right? So that's the termination. And then in the else block, right? In the else block, if you see, we are trying to identify the height of left node, and then we are trying to identify the height of the right node here, and then we are checking max of left height and right height. So that will be like something, right? And then we always return that counter, right? 1 plus. So let us see in action. I'm going to explain it here. Okay, so the first call to this function is height of node 5, right? This is what we are going to uh, pass. So the first function call will be height of, let me indicate as n5. This will be the first function. Okay, node is not equal to null because we pass node 5. Then the left height, let me indicate as LH. LH equal height of node dot left. What is the current node? It is 5. Height of node dot left is 5's left is 4, that is n4, right? So we are again calling that function height of n4. Okay, and then the next function call is right height, right? So it is in the queue, we did not call it. This will be only executed when this function returns a result. I will explain to you. Okay, so but let it put it like this. Let us put it like this. RH equal height of node dot right. What is the right node of 5? It is 8, right? So let me put it height of n8. Okay, then we are returning the result is, what is the result? We are returning 1 plus max of left height and right height. So let me put it like max of LH and RH. Okay, this is the result. So let us get into the real execution, code execution flow, right? So now code comes here, it evaluates left height is equal to height of node dot left. So it is going to call recursively height of n4 first. This is actually in the queue. These two statements are in the stack. Okay, these two statements will only execute if it returns a result. Okay, so I will tell that, okay, this is in the stack. Okay, these two statements are in this stack. Now let us evaluate. So let us evaluate height of n4, right? So height of n4 is what? So again this function will be called because it's a recursion. So node will be n4. Then it is going to do the same thing, right? It is going to do the same thing with node n4. So I am going to copy, so like this. So height of n4 evaluation, this is the evaluation, right? Height of n4 equal, what is the thing? LH, because it is going to call left height, right? Left height, sorry, LH equal height of, so left is what? It is trying to get the height of node dot left. Node n4 is what? This one. So node of left is 2. So it is trying to get the height of n2. Okay, in the queue, what will be in the queue? In the stack, sorry, in the stack, RH will be there, right? Right height will be there in the stack. So let me copy this. RH of what will be the node? Node dot right. The current node is n4. N4 dot right is null. So this is actually null. Okay, this is null, and the result will be, what will be the result? Same thing, right? 1 plus max of. So now let us go into the evaluation mode. When the code execution comes here, right, it will try to identify height of n2 first. What is the height of n2? It again calls the recursion, right? It again calls the recursion. So height of n2 is it comes here, it tries to evaluate LH of height of node dot left. What is the current node? N2 dot left means null. There is nothing here in this evaluation, right? There is nothing here. What is in the stack? In the stack, it will be like RH equal to height of this node dot right. Correct? So there is nothing there, null. Okay, and this is all in the stack. Okay, this is same thing because this is the same statement we are returning. So now the first termination happens here. So this is the execution flow, right? If you remember, this is the execution flow. Now this is the first termination uh, statement. So height of null means it returns 0 here. Okay, this will be evaluated to 0 now. Okay, so what is LH? LH of node 2 is now evaluated to 0. We got the result of LH. Now in the stack, this is waiting, right, to be evaluated. This is waiting to be evaluated. So now this will start evaluating. So this is actually in the rest is in the stack. So height of null means again it returns 0, right, because it enters into the termination logic. So RH is 0. Okay, RH is 0. Now what is now this will be executing. Result is 1 plus max of LH and RH. What is LH? 0. What is RH? 0. The result will be what? 1. Right? So this returns 1. Who called this height of N2? This guy called. Right? In our previous stack, this guy called height of N2. So height of N2 is now returned 1 from here. Okay? So if you look at the diagram, we are trying to identify the height of 4. So this guy returned 1 to here. So that is it. So here we got height of N2 as 1. Okay. So now this is actually returned as 1. That's the reason we got it. So this evaluation is completed now. When we try to evaluate height of N4, this evaluation is completed. Now stack has this value waiting. So this will be executing out from the stack. Okay, so height of null is what? 0. So LH1 RH 0. So now stack is going to execute 1 plus max of LH and RH. Max of LH and RH is LH is 1. Sorry, 1 second. LH is 1, RH is 0 in this case. So result is 1 plus max of 1 comma 0. Max of 1 comma 0 is 1. Add 1 to it, so the result is 2. So this is going to return a 2. Okay, 2 back to the here, because this is what the caller is, this one, right? You remember the caller is this one. So now height of N4 becomes 2. Okay, so that we evaluated the left side of N4, so we got 2 value here. You got it? Now this is waiting in the stack. This will get executed. Okay, height of N8. So now we need to, this is a time to expand, right? Because we didn't evaluate height of N8. Now this evaluation starts. Height of N8 is what? It again goes to here, right? It will find LH equal height of node dot left. So height of N8 dot left. N8 dot left is what? Null. Okay, so this will evaluate as 0. Right, and then it continues the same process. How we identify the height N4, that's the same way it is going to identify the height of N8. Then RH, since this is returning 0, height of null is 0, right? So then RH will start executing to the right. That is also 0. Then this is going to return 1 plus max of LH and RH. So this is going to return 1, right? So the height of N8, so in this right node is 1. So this will be 1. Okay, so the stack is, so we got the LH height and RH height for N5 now. Okay, LH and RH for N5 now. Now stack will execute this, right? We will get the next execution as 1 plus max of LH and RH. What is LH? 2. What is RH? 1. Max of 2 and 1 is 2 plus 1, 3. So 3 will be the height of this binary tree.